Hello everybody, in this new video we are going to have some small C# component where we will be able to find a curve on the ground, and we're going to split the ground surface in two surfaces where we can define on how much the distance is, and we will be able to offset the curve. Like bonus, we're going to review the changes in some human UI interface, and yes, let's get into the Grasshopper and see how we can get these two surfaces from the ground face. So as you can see, now I'm already in the Grasshopper environment. I have very simple 2 floors building with basic honeybee components and just random apertures with no only for the sake of a view of the building, some visual representation, because I'm going to need the surface down here, and I'm not interested in architectural aesthetic for this video, so excuse me for this. Now I have this one and the Breps already prepared, and I'm gonna need also in order to have the areas later on, I'm going to need the attributes here. So we need the face type and the area. This is the area and here is the face type, and together with shift I'm going to connect them in attributes. This I don't need this right now to be visible. Maybe I need some panels. Yes, in the one list, in the first branch we are going to see the floor and the area on the other side, so both are at the index 0. This is what I'm going to need, and the explode tree component. Because first I'm going to need the areas, and in the second branch the elements and the areas for my C# component, and for later also one data tree explode for the wireframes. So here 11. So here are all of the curves. When I click here, they're all green. So each one of the surfaces has the surface of the faces of the Brep has the polyline curve on the borders, and I'm gonna extract only this for the floors, also for later. And now let's get started to define this curve, that is going to split the Brep face on the ground. Okay, now at first place we have areas. So in my previous video I've already done something similar, but here it was interesting for me the method to take the curve in C# and to extrude, to offset this curve on some distance, and to split the Brep face into the two new surfaces. So this was interesting for me to see. I'm going to call these frames. Brep and the offset distance. So the areas were this branch, this is list axis, and the type is double. Also the list axis. And this is the string. The frames are here. Yes, this was curve. The Brep is this one in the beginning, and has of course the Brep type, and the item axis, the offset. There was some slider. Let's start with some integer. Offset in meters. For the output, let's take the area of the ground. The curve that I'm gonna need. Area out and in, you can write yourself the names as your logic is, because area out is the question is it is outside or the inside area, but I just left this right now like so. And the surfaces, which if I need them I can also grab them later. Okay, for now on I think this is the component, and the part in the human UI interface I'm going to, with this diagram, I'm going to make at the end. Okay, let's get started in the part with C#. I'm beginning to write here and make sure that you see everything. The first thing is I'm going to, just a moment, I need to see the C# component. So first I'm going to need to find where is the word floor, the string floor. This is at index 0, so I need for this index the corresponding area, the corresponding wireframe, and everything, the BrepFace for this index. So let's get started. This is list. I'm going to call this area ground. Integers, because there are the indices here, so 1 2 3 4 0 1 2 3 and so on. This is the first. With the area, then I want to find this curve on the floor that I'm going to offset. And last one, I'm going to find the faces of this Brep. So I'm going to explode the Brep and find which face, which Brep face is the floor surface. Faces index. Let's call this. Okay, this was the first part. And I'm starting to search for the word floor. So elements was this input, and here I'm going to loop through these elements and find if. So let's open the parentheses, and if the list elements contains open new one for the if. So if this contains floor elements, so please add to these lists the indices of the word floor. So we have the next one, and this one. Closing the if, closing the for loop. Okay, we are good, I think. I've gave here the area ground. So here I'm going to need the real area for the floor. So now we have here one surface for the area, but it could be that we have two levels. So I just going to, with for loops again, I'm going to collect all of the surfaces under index floor, which has the name floor from Honeybee Tools. And I'll define first the sum. And in one for loop again. Through the indices of area ground, our new list. These are the indices here. Sum. I have already the area, so this is my input, and here I'm collecting the areas under the index of area ground. This is the I index, so areas. Closing the for loop. Okay, let's just from here let's just control our output. So area G is going to be equal this sum. Panel. Yes, this is the sum. Going back to make the next area. So we need to split the, just a moment, where was it? We have now the area. Now we need the curve, the borders of this surface, and this curve is going to be offset in direction inside on how many meters we want, and we are going to split the Brep with this curve. So let's define the curve. Here is going to be some other list curve. I'm going to call this curve CFV. And here is the next for loop. Through the floor curves. So the floor curves were also here with the index with the word floor. Oh, sorry, here is count. Open. And to this list that I've defined it, I'm going to add from our input was with curves. So this was these frames here, which we also have access through these wireframes component from Honeybee. So from frames, the index of this floor curve, and closing this bracket. So I need to close this. This was the for loop for the curves. Okay, after this for loop for the curve, I'm going also to try to output the curve first. Yes, when I click the component, this is the curve that I need of the floor surface. And here the method is I defined like that the new curve. It's called curve 1, the offsetted curve. And I'm going to take the curve of the list, which we defined, offset. And I don't know why right now the autocomplete is not functioning. But what I need is to define the plane, the offset distance. Let's just say this is 5 meters, and I'm going to make it with the slider variable that I can change it, the tolerance, and it needs the style of the corners. I'm going to make it sharp. Let's see if this I can output now the curve 1. Yes, this is the inside curve. Still I won't be able, I'm not able to control it from here, but I'm going to change this very easily. So here above the curve I'm going to assign new variable. This is going to be our input offset. And on the place of the 5 I'm going to write the variable. Okay, now is working. I can change it. So the next, the method with the splitting of the Brep. This was a little bit tricky for me. So first, I can open the library. The split method that takes the curve is coming from Brep. But I've figured out, I think that is right. In order to access the surface of the Brep, I need the method BrepFace, which has not. I need BrepFace, which has not the method splitting. Let's see how we can do this. So here above, near the list, after the list curve, going to define new list, the class BrepFace. This is going to be my surface. Okay, it's similar for loop here. I'm going to throw out the faces. This was our third list with indices of faces. I'm adding to the new list. Our input was Brep. The whole Brep with all faces was here in the beginning. I'm taking this one, and it has already the method here faces, his own faces of the Brep, and I need particularly these faces, this index which corresponding to floors in the beginning. So face int, this index, closing the parentheses, closing this one. Okay, so surface, this is going to be my floor surface here, down here, yeah, and this surface. And after I find this, this is my BrepFace now. So also giving the name from this list, this is going to be, this is only one, so the 0 index is my BrepFace, which I've found. And to split this I need the class Brep here and array, because this is going to be 2 Breps, the out and the inside and outside one. This is going to be my result, the face which I've defined, and it is now the BrepFace, so I need to transform it again to Brep, so to Brep. And now I can find the method split, which takes the curve, so the curve 1, and the tolerance, for example. And what I'm going to output as is written here, area out. My Breps in result, under this index, I'm getting the area straight. The next area in, I'm getting the other Brep. And it is going to be nice if I can, with some geometry, I can take out the surfaces like geometry, not only the areas. So here comes just the Brep. Let's see what we have. Okay, so area out is some area, this is some area. Let's take a look at the hole and make addition on the in and out area. Yes, it gives the same number, and maybe some geometry output for the surfaces. This is the one green, this is the other, and by as we're changing this, the surfaces the areas are also changing. Okay, let's see the final part. I'm going to make simple graph in a human UI. So this is called multi-chart. Let's take the windows. Oh, sorry. This was the toggle to show. This is our empty. So for the areas, let's just take the number. I need the whole area and the both separate splitted areas. These are the data, and for the names, just add some panel and write the corresponding names. Ground total, and make it multi-line. Maybe the name I need are just simple areas. Okay, now I have the presentation. Yes, I can change this, and this changes also in human UI. So this was everything for this tutorial. Thank you for watching, and see you in the next video. Bye.